Okay, so this chapter, or this section, is going to talk about geometric sequences, something different than arithmetic sequences. Its difference, as you should know by now here, lies in, instead of using d, we're going to use r as a variable that identifies the common ratio. Okay, common ratio. So if you look at this sequence right here on letter A, okay, we have a 1, 3, 9, 27, all the way to 243. Here you can see each term is being multiplied by 3. Or you could say 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is 3. So here r, as you can see down below here, is 3. That's the common ratio. So there's no more common difference, and that is what a geometric sequence is. So hopefully you've taken a look at these examples. Here's the general term of a geometric sequence. So the only difference here is we're going to use this variable r, and then we have n, which is the number of terms, t1 is the first term, and a very simple formula. So when we look at practice problem 1, it says suppose there are 3 bacteria present in a sample and they double in population every time they reproduce. Determine t1, r, and the general term. Okay, so the sequence is 3. That's what you start with. It doubles in population every iteration, every time they reproduce. So you're going to get 6 for the second one, 12 for the third, 24, and so on. Right? So therefore r, what do you think r is here? 6 divided by 3 is the same thing as 12 divided by 6. Okay, 24 divided by 12, you can keep going, but that's going to be 2. T1 is 3. This question's asking you to find Tn, right? And Tn, your formula, is T1 times r to the n minus 1. Okay, so when you plug in what we know, we only know 2 things. We know T1 is 3, and we know r is 2. Now, believe it or not, you cannot simplify this. Okay, that is the answer. Okay, this is it. This is all we can do. That's the solution. This will generate any term you want in this geometric sequence. Okay? Moving on to practice problem 2, we'll get a bit more tricky. Suppose the smallest reduction a photocopier could make is 60% of the original. So I underline that for you. What is the shortest possible length after 8 reductions? I should underline after 8 reductions. Okay, if the photograph was originally 42 centimeters long. So the photograph was originally 42 centimeters long. That means T1 is 42. Okay. What is R? Well, it says each reduction will be 60% of the original. So that means you are actually multiplying each iteration by 0.60. That's what 60% would be in decimal format. Okay, so you could actually already figure out what the next term is. But that's not what the question's asking. The question's asking what will happen after, and here's the annoying part of this question, after 8 iterations. So n will actually be 9, because it's after 8 iterations. So 1 after that. So it's really not counting the first one, right? That's why n's 9. So here's T1, right? So the after 8 iterations, you'd be at T9. So really what you're looking for is T9. Right? Your formula is T1, which is 42, times R, which is 0.6, to the exponent n minus 1, so we 9 minus 1. When you calculate that, you're actually going to get a decimal, and it's going to be a very big decimal. Take this to 2 decimals, so that's what it would be to 4, but when you round to 2 decimals, and this is in centimeters, this is your final answer. Okay? So, this was the only tricky part of this question. Okay, was recognizing that. And you can actually even figure out, go 42 and multiply it by 0.6 8 times, and you'll see after that you're going to be arrived at this answer. Okay? Now moving along to the very last one. I already kind of have something written in here. It says in a geometric sequence, the second term is 28 and the fifth term is 1792. Determine the values of t1 and r and list the first three terms of the sequence. Okay, what I have listed here is this is the general form of a geometric sequence. We're going to do something very, very sneaky and clever in this question. It tells us that the second term is 28, right? And it tells us that the fifth term is 1792. So it gives you T2 is 28, right? And it says that T5 is 1092. Now I have written up here, I apologize, a way to find R in a very sneaky way, okay, or T1, depending on what you want to solve for. I'm going to find R in a sneaky way, and then to get T1, and then we can generate the first three terms with R and T1, right? So we know that T2 is equal to T1 times R, and we know that T5 is equal to T1 times R to the 4, right? Because the exponent of R is always 1 less than n. So we can actually solve this. Check this out. If you substitute 28 in for T2, that should give you that, right? I'm going to be looking for R, so I'm actually going to solve for R here. We don't know what T1 is, but that's okay because we have two equations. Okay, so that's equation 1, similar to the last question we did in the previous section. And now for this next one, we have 1792 equals T1, which we don't know, and R to the 4. Okay, I'm going to substitute R in for R to the 4. Okay. And actually, let me just erase this for a second. I'm doodling on my page here. Let's switch colors. Over here, I'm actually going to I'm going to solve for T1 because I'm going to solve for R over here. Okay, so I apologize here. So this will actually be R and T1, and then I'm going to substitute in to T1. Okay, so what I'm going to be left with is 1792 equals T1 is actually equal to 28 over R, and this is all times R to the 4. So this R will cancel with that, leaving you with 3. If you divide off by 28 over here, you're going to be left with 64 equals R cubed. If you cube root both sides, you'll be left with 4 equals R. Okay. That's how you find R. Very, very clever. Pretty quick. Once you have R, you can substitute back into this equation, or this one right here, to easily find T1. So 28 divided by R, which in this case would be 4, okay, is equal to T1. So T1 is equal to 7. T1 is equal to 7. Therefore, you can generate the first three terms simply by taking 7 and multiplying it by 4, then multiplying that by 4 once again, and you are left with your three terms. Okay? So take a look at the practice problems, finish them, check the solutions, and then move on to section 1.4.